Hello, everybody, and welcome to the Crypto Hipster podcast. This is your host, Jamil Hassan, the Crypto Hipster, where I interview founders, entrepreneurs, executives, thought leaders, artists, everybody really in the world of crypto and blockchain all around the world. And today I have an amazing guest. He is the founder of Radix DLT. His name is Dan Hudges. Dan, welcome to the show.
Hi, thanks for having me. Good to be here.
You're very welcome. Thank you for joining me today. So I'll kick off first. I think I interviewed a Radix person a few weeks ago.
I think
Uh, Adam, yeah, it went really well. I had a lot of listeners, so really looking forward to this. So let me ask you first, what your background is, and is it a logical background for what you're doing now?
I got into computers and programming and all that kind of fun stuff from a really young age. Like 5 or 6 years old, me and my father had old Spectrums and stuff, and we were tinkering around with those, making games and programs and stuff. And just kind of got the bug for that. I like to build things, take things apart. I was quite an inquisitive child. Sometimes my toys didn't go back together in the way they were intended, so that was always fun. And then just kind of kept up with that hobby, over the course of my young age and teenage years. I wanted to be a game developer. I was just obsessed with, I want to be a game developer. I've got some ideas for games, and kind of somewhat forced my way into that industry, and I didn't leave all the game companies that were fairly local to me alone with demos and kept pestering them, can I have a job? Give me a job. Look at all these cool things I can do. So that's kind of where I started in game development, and kind of transitioned into, 3D engines and doing all that kind of stuff for a number of years. And then transitioned from there into mobile gaming, and then mobile application development, worked on some very early mobile payment systems, using early iterations of the NFC chips, which obviously now are all the contactless payment stuff, and just kind of went quite heavy into mobile payments. And then after that was when I discovered Bitcoin, over a decade ago now. So, hey, this is really cool. Somebody solved this very difficult computer science problem that's been around for decades. Let me get into this stuff. And so initially it was kind of from a computer science consensus distributed systems point of view, but then very quickly also became kind of, appreciated the disruptiveness that the economic side of things could bring as well, all that self-sovereignty and permissionlessness and all those things. And, interestingly, in reply to your question, all of the things that I've done in the past have in a strange way kind of led up to this point, right? You started in games and 3D engines with very math heavy, and then mobile payment systems, which is obviously relevant, right? Payment systems in general, how they integrate with the world, what the hardware looks like, payment rails and all those things. And then kind of mobile application development on large distributed systems, with large scale carrier networks such as T-Mobile. Or the distributed side, and the experience of all that was from there. So it all just kind of comes to a convergence on all the things that I've done, and it's all very relevant to what I'm doing these days.
Excellent. That sounds very relevant. Great. So Radix DLT, what is that all about? What separates you from the industry peers?
I think the best way to describe the Radix and the journey that I've been on from those early days was, as I just mentioned, I got quite deep into Bitcoin from a comp science point of view, and spent some time playing around with Bitcoin and understanding how it did what it did, how it achieved what it achieves. But being a kind of engineer, I'm always looking for the inefficiencies, right, or the pinch points. And it dawned on me after a while that, if this thing really takes traction over the next couple of decades, and you have billions of people making payments and connected devices and all these things, Web3 as it now is the scale going to be enough? Is it going to be responsive enough? Is it going to remain decentralized enough, and all those kind of fundamentals take a look at how are they going to evolve over time. And so despite really wanting to build something on Bitcoin in the early days, I came to the conclusion that this is an amazing first step, but tech progression never sleeps, right? So maybe I can take a look at some of these problems and see if there's any solutions. And from that point, the rabbit hole just kept getting deeper and deeper. And here we are, 10 years later with Radix, which aims to solve a lot of those original bullet points on the list, I guess, plus a batch more, as the industry has progressed, and the user experience is still quite bad and the developer experience is still quite difficult. Additional things have kind of landed into that pot, because as we progressed on the fundamental tech, it's like, well, actually we could do this, and we can add this piece which makes things a bit better. So really the goal for Radix is to provide a efficient, streamlined ecosystem from both the fundamentals all the way up to the user and the developer experience that can scale to tens of billions of interactions and actors and devices. So it's very long play, which is unusual in this space, I think.
It is unusual, and there is I like to focus on scale and security. And there are some particular blockchains out there that are very short play, right, as opposed to your long play. And I think we should talk about one of them. Recently, you called out Solana Labs co-founder Anatoly Yakovenko for his limited understanding of blockchain security. Why will Solana someday be a network with compromised security if it's not there already?
Yeah, that was an interesting conversation. So me and Tully have bashed heads a few times on Twitter or X, whichever you prefer to call it these days. But that one got particularly kind of deep. And then on the back of that, I wrote an article, which I'm assuming you've seen. And it was the whole conversation really started around what's known as an honest majority assumption, right? And some of the claims that Tully was making, that sharded networks introduce honest majority assumptions where Solana doesn't. And you can extend that from his argument to other monolithic blockchains, right? So essentially, if you shard, then you get what's known as an honest majority assumption. And what that means, for your non-super techie listeners, is the whole premise of these distributed systems is the security is predicated on an assumption that you have to make that the majority of the network are honest, right? So the people who are running nodes and validators and making transactions and all of these things, that the majority of them are acting honestly, right? And by honestly, what that really means is they are following the rules of the protocol, right? So they're not trying to double spend, and they're not trying to subvert the protocol in any way. They're not trying to cheat or do any of these kind of things that go against the well-being of the protocol, let's say, right? There are some nuanced cases where you might have actors who are faulty, yeah? So, their validator isn't working correctly for some reason. That doesn't mean that they're dishonest, but they still kind of fall into the same camp of they're not following protocol, right? Because in that particular case, they can't, something's wrong with the machine or their internet connection or, something. And these rules around how many honest participants you need to have to guard against these dishonest activities from a minority, they're well defined, they're strict, and they're immutable, right? So depending on what your protocol is and how that protocol operates, the consensus protocol, you may have what is known as a 20% Byzantine tolerance or a 30% Byzantine tolerance, right? And what that is saying is that so long as 66% of the network is honest, and 33% or less of the network it can guard against 33% of the network being dishonest, right? So if you have 100 actors in the network and 34 of them are dishonest, then you can potentially run into issues, right? And you may not even necessarily have any evidence or knowledge that 34 of those 100 actors are dishonest until the point where things start to go wrong, and then it's likely too late, right? So really the argument that we were having that then kind of wandered off into all these other subtopics, which, you know, changing goalposts, et cetera, always seems to be a fun thing that happens in crypto debates, was that my point is there is honest majority assumptions everywhere, right? Because even the fundamental operation of a blockchain relies on an honest majority for the network to function and to be secure. So it doesn't matter how many layers you go up, if you try and move some of that assumption down to the next layer, you know, to solve some problem here, and then take it down another layer down the stack, and then another layer, then another layer, eventually you just bump into that fundamental honest majority assumption that underpins all of that stuff. And the argument was that these honest majority assumptions are everywhere, so it's kind of moot to argue that sharded networks have honest majority assumptions when unsharded networks do too. And Tully's argument was that they're different honest majority assumptions, but ultimately it doesn't matter because there's a grandfather honest majority assumption that sits underneath everything, and eventually you just bump into that anyway. So that's kind of the crux of the argument. And then, you know, there's all these different examples that we went into, and double spending and Circle, and how they would just ignore what the network is doing, but then there's consequences for them doing that and all these other things. And it just kind of really surprised me that that's the way the conversation went. When, you know, Solana is a $100 billion plus cryptocurrency, and this concept of there is an honest majority assumption everywhere seemed to fall on deaf ears.
So, interesting. You know, I run a pretty good ship here at Crypto Hipster Podcast. I don't do things like I saw a few years ago, where I think it was a Bankless podcast or something, where, you know, that the head of the leader of Masari came on when they're interviewing, you know, Sergey Nazarov on Chainlink, and he started playing a ukulele. I don't do that. I just call, you know, I go straight to the punch with ethics. You know,
Sure.
you know, you explain the untrustworthy actors, and you know, I saw for the past year a lot of shillers on social media about Solana. And, you know, I'm thinking maybe it is 50-50, or it's beyond, it's beneath the 66% threshold. I don't know. I do know that there were a lot of downtime occurrences on Solana, and I didn't think it had security to begin with, right? How was it compromised already, and what do you think they can do to improve that?
I wouldn't say that the downtime is because of security, or maybe lack of it, right? From my understanding, most of the Solana downtime issues have been, you know, bugs in the code or things wrong in the implementation, which can always happen, right? You know, you can have perfect theory up to the limits of the theoretical, but then, you know, you only need one developer to be, you know, out of Red Bull and pizza at 2:00 in the morning and make a mistake, and that can potentially cause, you know, some downtime in the network somewhere. So I wouldn't say that all of the downtime has been security related. I would say it's more likely implementation and bugs and things. But that, if the theory itself is lacking in areas, then even you can have the best implementation possible, and your security can still be weak, right? Now, I'm not close enough to the Solana ecosystem, and I'm not in the weeds enough into Solana theory to be able to say to you, yeah, Solana's got a security issue because of this, right? If I spent a lot of time looking over the fence into the neighbors' gardens, then my own garden would mess pretty quick, right? So I just tend to, take a more kind of higher level approach and review these technologies that are being built. And because of my experience, there's some fairly obvious things that you look for first, right? Does it do this? Does it do that? And if it doesn't do some of those things adequately, then you can maybe say, there's potentially some security issues here, right? But to go any deeper and to look at the real nuance of security, that takes time. And unfortunately, in this line of work, most founders are time poor. So, but when you have conversations like the one that I've had with Tully, and you get into that kind of security theory, those conversations can also raise concerns, which is what I have after those conversations with regard to Solana, right? If that's the train of thought from, in quotes, those in charge, then do they really understand the security, or was the shifting of goalposts and conflation of topics just a means to win the argument, right? Because it could also be that. So I don't know. I keep an open mind, but yeah, there's certain things that make me raise a red flag.
So I want to find out, like, say, for example, it doesn't just have to be Solana. It could be Ethereum. It could be Bitcoin. It could be anybody, right?
Yeah.
If the majority of validators in a network are not honest, how can they mislead full nodes into accepting an incorrect state?
So you've got kind of two kinds of attack vectors there, right? Number one is, depending on how those full nodes are verifying the state, then there may not be a double spend as such in the traditional sense, but they can be fooled into accepting a state transition that might have been wrong, right? Now that depends a lot on the implementation of the security, right? If there's a bug there, then they may not verify that state transition correctly, right? That's probably less likely to happen because state machines and the execution models that are used in these systems are deterministic in nature, right? You put the same inputs in, you get the same outputs out. And so that kind of forms a foundation for how state transitions, tokens A going from token A going from, Bob to Carol, for example, right? The deterministic in nature. So if you are going to verify a state transition, then you want to have the inputs that we used, you want to have the outputs that we use, right? Now, if the network is compromised, then you may ask for those inputs and outputs, and you won't be sent them, right? Because by sending them to you, that might expose either a bad state transition or may expose the intent of some, attack that may be mounted in the near future, right? So your adversary will, try to cover their tracks from certain individuals. And the thing to remember here is that when you're thinking about security, you always ultimately have to think about what's known as a strong adversary, right? And a strong adversary has complete view of the network, can see everything that's going on, is able to isolate people in the network, validators and nodes and clients, isolate them from other parties in the network, so that those parties who have been isolated can be fed one set of information, and then other parties who have been isolated can be fed another set of information. And obviously you don't want those two isolated groups to be able to talk to each other, right? Strong adversaries they essentially have, godlike powers, for want of a better word, right? They can see everything. So if you're dealing with an adversary of that kind of strength, then you can create multiple proofs that may, execution proofs, right? Like in the case of Altus and stuff. Yeah. And you can create forged copies of those. You can create those signatures with whatever information you would like to have in them, because ultimately you control the network, right? and you can isolate parties from each other so that they can't see these two conflicting things until it's too late. And the same with a double spend, right? If the network is compromised, then the adversaries can create two completely different versions of history and give those two different versions of history to different people depending on what their attacker's doing. In the case of a double spend, right? They give one version to use Tolly's example, they give one version to Circle, and because they're a strong adversary, they know which of all the nodes in the network are Circles, so they isolate them. From Circle's point of view, everything is fine because I'm receiving transactions, I'm receiving blocks, all the blocks check out, all the signatures check out, all the proofs check out. But everybody else who's not Circle in the network is getting a different version, and they're also all happy because, okay, the blocks check out, the signatures check out, the proofs get out, check out, we're all good. And then whatever the attack is, it happens. The adversaries leave, everybody can see each other again, and it's like oh shoot, we've got a problem here. Circle have got one version, we've got another version. How do we reconcile it? And that's known as a safety break, and they're generally devastating.
Okay. I'm thinking about strong adversaries.
One other point, right? If you're a strong adversary, different types of adversary potentially need different amounts of control in the network, right? So if I'm a weak or medium strength adversary and I have 34% of, say, hash power or stake in the network, then depending on the consensus mechanism that's used, I can cause what's called liveness issues, right? So I can essentially halt the network. Yeah, I can't do safety breaks easily, but I can halt the network, which isn't great in the first place, right? Because people are trying to make transactions and none of them are going through, they're timing out or whatever, and nothing gets processed. But if if I want to cause safety breaks, but I'm a weak or medium strength adversary, I generally need 67% of stake or whatever the influence metric is in the network. And I can also then, of course, cause liveness breaks as well, right? So if I have 67%, I can vote on what I want. I can create different versions of things. I can send those around. I can double spend. I can do all this stuff, right? If I'm a strong adversary, then in the worst case, I only need 34% for that as well, because I can isolate the remaining 66% of stake, let's say. Yeah, I can isolate them from each other, 33% on each side. In order for consensus and state transitions to happen, requires a supermajority of 67% of vote power, right? I've got 34. There's a isolated group over here with 33. Add them together, got 67. And there's another isolated group over here with 33. I've got 34, but I'm going to double vote because I can, and I'll get away with it because I also have another 67%, right? So if you're a strong adversary with 34% or more, you can do those kind of things. You can cause double spends and safety breaks and all this stuff. So it very much depends on how much influence you have, how strong you are as an adversary, what tools you have at your disposal as an adversary, if you're able to isolate and eclipse different groups. So it's kind of a sliding scale, but obviously security, when you're thinking about security in the purest sense, you always want to think about who is my strongest adversary that I'm going to be up against.
Got it. So when I think of adversaries, I think of the SEC, Elizabeth Warren, the Chicago hedge funds who shorted Terra Luna, stuff like that. We're talking about on-chain adversaries, right? So
yeah, that's kind of like academic nomenclature for consensus mechanisms and stuff. Yeah, distributed system.
Yeah, so I'm thinking, how can there's been rug pulls, there's been hacks, there's been bridge attacks, there's been everything you can name. Actually, I had a scammer reach out to me yesterday, and he was failing miserably. Then he resorted to begging, and I was like, no, I'm not going to let you scam me. Bye. How can people who aren't coders and aren't technologically savvy begin to discern where there are security issues?
Yeah, the problem with security issues is that they live all over the place, right? So, those kind of security issues that we've been discussing so far, they're very much low level at the protocol, right? So the blockchain itself. the mechanisms by which the blockchain secures itself, or the distributed ledger, or whatever distributed system you might be using. It doesn't necessarily have to be blockchain. But then you have different security domains that sit on top of those things, right? So in the case of Ethereum, for example, you've got the Ethereum proof of stake blockchain, right? So all the stuff that we've just been talking about lives there, yeah, in the protocol, it's protocol level. But then on top of that, you've got the EVM, right? EVM sits at the top. So there are a bunch of different security domains in there, right? To do with the language, how, reentrancy, loading of state, writing of state, execution. There's a load of security stuff that happens there, right? Which doesn't necessarily have any issues in the same way that the protocol level does, right? Then on top of Ethereum virtual machine, you then have the individual smart contracts, which also then potentially have their own set of potential security issues, right? Like the developer didn't understand exactly what they were building or how to build it, or they didn't understand enough about the Ethereum virtual machine, so they made some mistakes, right? Or they didn't understand the security that was required from that application they were building and how that security relates to the rest of the system and stuff. So you have these multiple layers of various security surfaces that can have different kinds of issues, but ultimately from a user point of view, the result is, I lost funds, right, in these kind of systems, or I got rugged, right? Like getting rugged isn't a problem in the Ethereum protocol. It's not a problem in the Ethereum virtual machine per se. It's maybe not even a problem in the smart contract. It's just that the person who built that smart contract has all the keys, right? And then they can just withdraw the liquidity. And that's not anything to do with the stack at all. Yeah, that's just a dishonest person that's built this smart contract with the intention to rug everybody that uses it. So you've just got to be diligent. If you're a non-technical user, don't click on anything that a phishing email or send this transaction to give us access to this token in your wallet. Well, is it really just getting access to that token in my wallet, or is it just a general purpose authorization that has access to everything in my wallet? And then when I wake up tomorrow morning having my coffee, all of my funds are going to be gone, right? There's so many different areas where you have to be diligent. And that's difficult for your normal user, right? Which is part of the reason why our mandate at Radix is to improve that experience as well, the user experience, the security for the user, and all these things. So, we can't stop rug pulls, for example, but we can make sure that the user is more informed in a human readable way about what's going on with any transactions that they make, right? And maybe if they see something, whoa, hold on, that's not what I want to do, right? Cancel, I'm not doing that. Instead of it just being, a hash code or some hexadecimal and nobody knows what the hell it means, and they just click, yeah, but I want to degen into this, so click anyway, right? So yeah, just be aware that there are many, many different layers of security and things that can go wrong.
I see that all the time on Twitter with people degen into things without understanding anything. And
yeah.
Some of them make a lot of money and most of them lose all their money.
Right.
So,
and maybe if the user experience was a little bit more informative and a bit more human, maybe that would be less, right? Because it's in your face then, yeah? It's like, don't do this on the screen, right? Are you sure you want to do this action? It's, well, let me think about this decision a second. Which, small things can make a big difference.
Yeah, so let's talk about small things making a big difference. We talked about so far about security, right? I want to talk about this concept of economic security, right?
Yeah.
Which is different than cybersecurity. And
yes.
what you at Radix are building to help people with their improve their economic security.
So economic security, again, it's like a network-wide surface, right? And it complements your protocol security, because you think about economic security. Proof of stake is a really good example to use, right? So we'll go with proof of stake. So if I want to have a validator and I want to contribute that validator's compute resources to the network, then I will have some stake on that validator, which allows that validator to vote for things, right? There's a block of transactions, and those transactions come in, the validator verifies them, and if all the transactions in that block are good, that validator will vote with its stake to say, I attest to this block, right? Everything looks good. As far as I'm concerned, we can accept it in the network. And then all the other validators with all of their stake do the same thing, and they vote. And if you get a supermajority, 67% or more, called a quorum of stake voting for that particular block, that it's all good, then it'll be committed, right? And the transactions will process and everybody's happy. So that's your kind of your raw protocol security part, right? I have some tokens, and that gives me a portion of vote power, which is proportional to all the other validators in the network. So if all the validators have, say, 100 million tokens, and I've got 3, then my vote, I have 3% of influence over the vote, right? If I have 10%, then I have 10% of influence over the vote. And if I have 34 million of those 100 million, then I can do liveness breaks and other potentially horrible things, right? So where the economic security comes into play is more around the value of those tokens, right? And not so much how many a particular validator may have under its control, right? So if there are 100 million tokens, but they're all worth, a millionth of a cent, then the amount of token value securing the network is maybe only a few $100, right? But if the value of each of those tokens is, say, $1, then you've got $100 million securing the network. And where that then becomes important is if I am an adversary and I think, okay, I want to attack this network, I've come up with this really good plan on how I can double spend and nobody will see it, and I think I'm all smart and I've figured out all the security details and I've found like a little path through, I need 34% of influence. That means I've got to go and spend $34 million, right, to buy 34 million tokens, yeah? Well, in actual fact, I would actually need to buy more in this case because my 34 million would be added to the 100 million. So I'd actually need to buy about 50 million tokens, right? Because I will be then adding those tokens to the stake. And so, I need to have more than the 34. But then just the mere act of me going and buying $50 million worth of tokens potentially pushes the price up, right? Especially if I do it quickly. Yeah, I want to do this attack tomorrow. I know that all these tokens are going to be there on next Wednesday, and I've figured out a way that I can kind of steal them or double spend them or whatever. I need to buy $50 million of this token over the next 7 days. The price is going to go up, right? So then I don't need 50 million. I need maybe 75 million or maybe even 100 million, yeah, because I've moved the price up. So that then becomes a potential problem because I need to acquire these tokens. And I can go and try and collude with some of the other validators, but if they are all strictly honest, then they're not going to potentially succumb to my charms of, hey, if you let me vote with some of your tokens and we'll split this nice payday at the end. If they're honest or they're risk averse or the risk seems too high to them, they're going to say no, right? I'm not going to let you vote with my tokens because if it goes wrong, I'm going to lose all my tokens through slashing or some other penalties, right? And so that component of economic security is really it's the cost required to mount an attack, right? And the bigger the network, then the more it would cost. So if the network is worth 100 billion, and 10% of all the tokens are staked, which doesn't sound like a lot, but then when you look at the value of those tokens, right, 10% of 100 billion is 10 billion. Then an attacker will have had to have bought $3.5 billion of tokens in order to mount any kind of attack whatsoever, right? So the economic security, it becomes a disincentive in many ways, and it also filters who is able to even consider mounting an attack, right? It's like Joe on the street couldn't think about coming in with $3 billion and making an attack, right? He doesn't have $3 billion. So the pool of people that could even mount an attack reduces significantly to, large corporations or very wealthy individuals or governments potentially, right? But the pool is then very small. And then you get socio-economic security, which is because that pool is very small, what would the consequences be from a society's point of view, right? If I'm a wealthy individual and I make an attack on a network, then if I get found, what are the consequences of that from a legal point of view, from a social point of view, right? All of my business associates are going to, no, screw you, I don't want to talk to you anymore, right? You tried to mount this $1 billion attack on this thing, right? It becomes a social risk as well, right? I'm going to lose my standing in society if I get exposed. And in the worst case, I might not even pull it off and get exposed, right? I might burn through a few billion and I get taken to court and none of my friends and business associates want to talk to me. So it just becomes irrational to do those attacks, right? And so the irrationality of it and the cost of it really becomes a deterrent instead, as opposed to a prohibitive cost.
That makes all the sense in the world to me. So I'm thinking, could BlackRock, MicroStrategy, and other big players get together and do an attack on Bitcoin? But supposedly, if the math checks out, they could have over 50%, but they wouldn't, because that would destroy their companies because of the bad will.
They'd be screwed, right? Because it was like, okay, who's performed this 51% attack on Bitcoin? Who has enough money, right? Who has enough resources to do that? Okay, that leaves 100 people, right? Okay, where have these 100 people been up to the past 6 months, right? You know, and these are all fairly public figures in the space, right? Or the company accounts and all these things. Oh, why is company XYZ suddenly buying up 100 million Bitcoin miners, right? What's the reason for that? And then Bitcoin's just had an attack, and there's a 51% attack. You can join the dots quite easily, right? Because you only have a small pool of people that could pull it off. So you're able to eliminate very quickly and get to the bottom of who was likely to have done this. And then, yeah, the social, legal consequences, your reputation's dead, right? You're just dead and buried. It's more profitable, to be honest.
Yeah, makes sense. It's more profitable, to be honest, and I think that goes in every area of life. So
yeah, it does. Yeah. You can get a quick win sometimes by committing a crime, and occasionally people get away with it, right? But I think the mantra is be honest, be happy, be profitable.
Yeah, I agree. Well, I want to thank you very much for your time today. I really enjoyed speaking with you, and this is a great conversation. I have one last question, and it's, how can people find out more information about you, about Radix DLT? How can they, who can they look forward to? How can they do that?
Yeah, so you can follow me and Radix on Twitter. My handle on Twitter is @Fuseleer, FUSERLEER, and then Radix is Radix DLT, RADIX DLT. And then you can go to our website. You can join our Telegram communities. We've got Reddit subreddit as well that you can join. We're all the usual suspects of how to get in touch and read up on us. We've got quite an exciting year this year with Breakout 2024. We had Project Ignition earlier in the year, which was a huge success, where you could lock up various token types, including wrapped BTC and wrapped Ethereum for rewards. It brought liquidity into our ecosystem. People can trade or more of the token types that they're used to, right? We've got bridges coming soon as well, so we'll be able to pull more liquidity in from the rest of the ecosystem. Token Trek went live a couple of weeks ago, which is like a fun kind of quest stroke educational initiative that we did in order to get people into the Radix ecosystem, start using what we're doing, and you get some rewards for each quest that you complete. Super staking has just gone up today, which is if you lock up your liquidity pool receipts, then you get bonuses and incentives to do that over a period of time as well. And then over the next month or so, we have a very interesting, very large gaming project that will be going live, which I can't say much on because it's all very hush hush and secret. And then we also have all of our kind of public-facing scalability testing that we're doing, which is going really well. That's the bit that I generally head up because it's R&D and test nets and stuff. And recently, on in the latest test, we hit 200,000 swaps a second on that network, not transactions, swaps, smart contract swaps. And there's nothing else out there that's even close to that. It's an order of magnitude more than anything else, and still growing. So exciting stuff coming down the pipe.
Awesome. That sounds awesome to me. Thank you very much for your time today.
Thank you for having me. Thank you.